Overview. Weather radar utilizes microwave signals to detect precipitation ahead of the aircraft by measuring the time delay and intensity of the reflected radiation. As well as weather detection, the system is also capable of turbulence detection and ground mapping. Weather, turbulence and ground mapping are indicated on the system's display on the center console. The radar display may also be repeated on the EFIS ND. Introduction. A transmitter-receiver in the forward equipment bay transmits microwave pulses at a frequency of 9.345 GHz. The short bursts are transmitted and received through a 24-inch flat-plate antenna. The wavelength of 3.2 centimeters is optimized to efficiently reflect large water droplets. Small cloud droplets will not be effectively detected. Weather detection is available up to 320 nautical miles ahead of the aircraft. A turbulence mode is provided, which detects the Doppler shift of the received pulses as they are reflected off water droplets having a horizontal velocity component. The system is not capable of detecting clear air turbulence. To provide large area cover, the antenna scans in azimuth through 80 degrees left and right of the aircraft centerline. The scanner is automatically stabilized with reference to the horizon by the IRS number 1, with a mechanical limit of plus or minus 15 degrees in pitch and plus or minus 30 degrees in roll relative to the aircraft axis. Following failure of IRS number 1, stabilization is transferred to IRS number 2 using the attitude heading switch. Manual tilt is available to 15 degrees above and below the horizontal. However, if the mechanical limits of stabilization are reached, tilt control authority will be reduced. From where does the weather radar receive its reference to provide antenna stabilization? Radar display. The display unit comprises a display and an integrated control panel. Off. Off removes power to the system and also acts as a standby mode. Test. Rotating the mode selector to test enters the test mode. The test pattern appears and the bright control may be used to adjust brightness to the required level. Note that the range, as selected on the range control, appears on the display above the test annunciator. The marker annunciator indicates the interval between the range markers. Antenna tilt is indicated in degrees either above or below the horizontal. The test bands should be checked as complete. When the system is active, the colors indicate black, Very light or no returns with a rainfall rate of less than 0.7 millimeters per hour. Green, light returns with a rainfall rate of 0.7 to 4 millimeters per hour. Yellow, medium returns with a precipitation rate of 4 to 12 millimeters per hour. Red, strong returns with a precipitation rate greater than 12 millimeters per hour. Magenta indicates the presence of turbulence associated with precipitation. Weather. Selection of weather immediately places the system in the normal operating mode, requiring no warm-up period. WX appears as the operating mode. Changing the range control will change the display of weather accordingly. Turbulence. By selecting Turb on the display unit, turbulence detection is enabled and will be displayed as a magenta overlay on the normal radar weather indications. Turbulence of a moderate or severe intensity is detected and is only capable of being displayed within 40 miles of the aircraft. Beyond 40 miles, the system will operate as a normal weather radar. The system cannot detect the presence of clear air turbulence because it relies on the presence of precipitation. Map. Selecting Map will enter the ground mapping mode. This mode will use similar convention to the weather mode by using the same colors. Green, low reflective returns. Yellow, medium reflective returns. Red, high reflective returns. Gain control. The gain knob is used to control the receiver's sensitivity in the weather and map modes, enabling the display's definition to be increased. The auto position is detented and the system is automatically calibrated. When the gain control is not in the auto position, Cal appears on the display to indicate that the function is out of calibration. Manual gain setting is also indicated on the display. Max, maximum gain. 1 to 9, relative gain. Min, minimum gain. The AUX button is intended for use when a checklist is displayed on the radar display as a customer option. Selecting AUX with no checklist fitted will display no AUX data. Radar display on EFIS. The weather, turbulence and map displays may be repeated on either EFIS ND by use of the weather control associated with the ND dimming control on either EFIS dimming panel. In which EFIS formats can weather radar information be displayed on an ND? The control is detented in the weather off position. Rotation clockwise increases the relative brightness of the weather display. The mode and tilt angle shown on the left of the ND are the same as selected on the weather radar display. The range is set separately on the ECPs. The selected ECP range controls the range of the weather information on the ND, independent of the range selected on the radar controller. This enables 3 different weather displays in the flight deck. What is the effective range of the turbulence mode? Before takeoff. Before leaving the gate, the system test should be performed. During taxi, but well away from all buildings and obstructions, the shortest range should be selected and the antenna down until ground returns appear on the display. In presence of storm activity, when lined up on the runway before takeoff, the weather radar system should be set to an appropriate range for the departure track. The antenna should be tilted from 0 degrees to plus 15 degrees and back to plus 4 degrees whilst searching for any significant weather returns. Manual gain may be used to assess the relative intensity of multiple storm cells as an aid to planning avoidance of the worst areas. As manual gain is reduced, red areas become yellow, which eventually become green. The areas which remain red for the longest time are the areas of greatest activity. Climb. Takeoff should be made with the tilt control set at plus 4 degrees. During the climb out, the antenna tilt angle should be set to plus 15 degrees, then reduced until ground returns appear, before again being set to plus 4 degrees. Cruise. During the cruise in storm conditions, the radar should be used efficiently to ensure that all weather returns ahead of and below the aircraft are detected. After reaching cruise altitude, range should be set to 40 miles and the tilt angle set to minus 10 degrees. While observing for any weather returns, decrease the tilt angle until the first ground returns occur. This ensures that any activity below the aircraft is detected. This procedure should be repeated for each range setting up to the setting appropriate for the current leg. Mapping mode. Although the weather radar is designed for the detection of weather, it may be used for ground mapping purposes. The antenna tilt should be reduced until ground returns appear. Manual gain may then be used to aid definition. Descent and approach. During the descent and approach, the tilt control should be adjusted upwards to prevent unwanted ground returns. Failure annunciation. The radar system is continually tested. Any failure detected is indicated by an annunciator on the radar display. Failures are classified as soft or hard. Soft failures. A soft failure is indicated on the radar screen as one of the following. Cal. System is out of calibration. Targets may appear weak. Stab. System is stabilized with respect to aircraft, but no pitch or roll stabilization. This causes heavy rain returns on only one side of the display during maneuvering. Cool. System cooling fault allows only partial use of the system. Use only as required to analyze weather. The radar system will continue to operate with a soft failure. Hard failure. A hard failure is indicated following a serious system failure. The entire radar display is removed and replaced by any of the following. RT fault, RT unit failure. ANT fault, antenna fault. AT fault, attitude fault. IND fault, indicator fault. Cool fault, RT unit cooling fault. If any of these warnings appear, the unit must be switched off to prevent further damage. What is shown on the weather radar display if the aircraft is banking and the antenna stabilization fails?